Simplifying nth roots. Up until now, we've been focusing only on square roots, but we can actually have third roots and fourth roots and higher degrees, or indices in this case, of the roots that we're taking. When I have a radical symbol, the number that's sitting up here in the corner, that's called the index. If there's not a number sitting there, we assume that it means that the number is a 2 for a square root. The number that's sitting there is telling us how many of an object we need to simplify that root. So if I, for example, had the cube root of 8, I know that 8 is 2 times 2 times 2, and I need 3 of the same items to simplify that to end up being 2 overall. It's asking me what number multiplied by itself 3 times will end up giving me the number that I see. So looking at example A, I see that I've got a negative sign. Whenever we have an odd number as the index, we can actually have negative numbers underneath the radical, because I know that if I have 3 negative numbers that are multiplied together, overall that'll give me a negative number. For now, we can't have negative numbers if they're in a radical that has an even number, like a 2 or a 4, but it's okay for us to have that with odd numbered indices. So I know that I'm expecting that the number I'm looking for is going to be negative overall. And so I just need to kind of think through what number multiplied by itself 3 times would give me 216. And I think the answer is 6. 6 times 6 would give me 36. And then if I multiply 36 by 6 again, let's see, 36, carry the 3. Yeah, it looks like 6 times 6 times 6 will give me 216. So if I wanted to be really precise with what I'm writing, I'll write that negative 216 is these 3 items written like this, and that simplifies to just negative 6 as my answer. All right, moving on to letter B. Let me make a little bit more room here. There we go. I've got the fourth root now, so I want to try to find some numbers that maybe 80 can be broken down to simplify that. In the denominator there, that fourth root of 5, I don't think that I have a good way of breaking that down, because 5 is just a prime number. It can't be split up anymore. Let's think about 80. 80 is 8 times 10. 8 is 2 times 2 times 2. And 10 is 2 times 5. Looks like I have 4 of these 2's sitting there, which is helpful. So let's see. I can rewrite this as the fourth root of 16 times 5. Let me move this over. And then just the same way that we do with square roots, I can split these fourth roots up into to be separate components. And I know that the fourth root of 16 is 2. And then now I've got this fourth root of 5 and fourth root of 5 that are going to cancel each other. So it looks like my answer overall is just 6. For example C, we want to rearrange the cube roots that I have. Hopefully we'll end up with 2 things that are like terms, so we can add these items together. Let's do some side work and think about 9,000 to start. 9,000 is 9 times 1,000. And 1,000 is 10 to the third power. So that works out nicely. I'm going to break this up into the cube root of 1,000 and the cube root of 9. The cube root of 1,000 is 10, So I've got 60 times the cube root of 9 for my first term. Now let's think about 576. Let's see, I just start guessing numbers. That's divisible by 3. I just start thinking about numbers that I can break it down by and see if I get anywhere. That's also divisible by 3. (64), I know that 64 is 4 times 4 times 4. So it looks like for 576, I can break that up into the cube root of 64 times the cube root of 9. I've got 64 sitting here and 9 sitting here. Well, that's good. This looks like this is going to end up working out. The cube root of 64 is 4. Oops, let's fix that. And then I've got 28 cube root 9. Now I've got like terms because the cube roots of 9 are the same. That can't be simplified anymore. So then I'll just add 60 and 28 to get a final answer of 88 times the cube root of 9.